Today class, we'll be continuing our class, and today we're going to be looking at C++ data types and variables. C++ data types and variables. In the last class, we looked at the introductory part of C++. We looked at a very simple code to display hello world on the screen, and we emphasized that when you're writing your C++ program, there are some statements that you will almost not omit. That is to say, in all your codes, they are likely to be there. One of the statements is #include IOStream, and I said that it is a header file that contains your input and output objects that helps you perform input and output operations in your C++ programs. So if you are going to be performing input and output operations in your program, you will always need to include the header file called IOStream. Then we also made mention of using namespace standard, which represent the standard library. That is to say, where your standard files are kept, meaning that anything that you didn't define in your code, you are asking the compiler to look for it in that standard library. So we said that, and we also said that there is a method called main, or function called main, that your program must always have if this program is to execute. That main is the starting point of your program execution. So if you are going to have a program that consists of 10 functions, those 10 functions should be main and 9 others. If you are going to be having a program that consists of 2 functions, it's going to be main and 1 other function. If your program is going to contain just 1 function, that function can only be the main function. So we said that, and we also said that any function that have a return value should end with return statement. So today we are continuing our class with data types and variables. So let's look at data types. What are they? C++ provides a rich set of built-in data types to handle various kinds of data, such as numbers, characters, and Boolean values. These fundamental data types are essential for declaring variables and defining the kind of values they can store, determining the amount of memory allocated for them, and the operations that can be performed. So when you declare a variable of a particular data type, you are saying so many things without knowing. What are the things you are saying when you declare a data type, a variable in your program of any data type? One, you are specifying the kind of value that can be stored in that variable. Is it going to be numbers? Is it going to be characters? Is it going to be floated values? Is it going to be Boolean values? And so on and so forth. So when you declare variable of a particular data type, you are specifying the kind of value it can store. Apart from specifying the kind of value that variable can store, you are also specifying the amount of memory that should be allocated for that value. So when you declare a variable of a particular data type, you are not only saying the type of value that can be stored in that memory and in that variable, you're also specifying the size of memory that should be reserved for that variable. And finally, you also are specifying, without knowing, the approved operations that can be performed on that data. So you don't just declaring variable of any particular data type is not just a simple statement. As simple as it appears, it is providing these 3 information: the kind of value, the memory to be reserved for the value, and the kind of operations to be performed on that data. So understanding these types is crucial for efficient memory management and writing effective C++ programs. The size of some data types can vary across different systems and compilers. You may be reading books, maybe you check this book says this data type can have this size of memory, another book will say this and all that. So the type, the size of these variables, of this data type, they vary depending on the type of system you are working on or the type of compiler you are working with. So some of them have varying sizes. They have varying sizes, and the reason why they have varying sizes is because they may be running on different system architecture or the different compilers or even different operating system. Okay, so let's move ahead. Let's look at the fundamental data types in C++. So we have a table. In the table, the first column is the data type. The second column is the size in bytes that will be reserved for any variable that is declared of this data type. And then we'll have a little description about the data type. So the first one is the bool. Bool is a short form for boolean. So when you declare a data type a variable to be of type bool, you mean it's a boolean value. So the size for the value in memory is just 1 byte. And what does it store? It stores boolean values which are either true or false. These are the two values a boolean data type can store. It can only store the value true or the value false. Then the next data type is the char. The char data type or the char data type. It is also 1 byte in size. And what does it store? It can only store just a single character. A single character. Then another form of it is the unsigned char. Unsigned character, it's also 1 byte. It stores a single character that are represented as the value 0 to 255. You know, when we talk about character, we say it stores a single character. Yes. But somehow behind the scene, it is not really the character that it stores. Rather, it stores the ASCII value or the ASCII code for the character. So when you say it stores the values 0 to 255, what we are trying to talk about is that the value that is represented by ASCII code 0 to the value that is represented by ASCII code 255, those are the values that the unsigned char can hold. So if you check your ASCII table, you'll be seeing what these values are. If you download your ASCII table, you will look at the value that is decimal number 0. So you know the symbol. If you now look at which value is decimal number 60, decimal number 95, each of these values is actually what that is stored in char. But when you display, when it prints, when you want to output the content of a char data type, it will now output the symbol. For instance, capital letter A is 65. So when you assign A, capital letter A to a char variable, what you're actually doing is that you are assigning 65 to it. But when you want to output the value, it will not output 65. Rather, it will output the symbol that 65 represents. So that means inside it carries a number, but outside it displays a character. Also, when we have a signed character, signed char, it's also 1 byte. So it now represents single characters between minus 128 to 127. Single characters between minus 128 to 127. So we have another data type called short. Short is for integer. It's actually a way of saying short int, but it's written just as short. When it is written as short, it means short int. It is 2 bytes. It is 2 bytes. That's short integer. 2 bytes actually mean 16 bits. 1 byte is 8 bits because 1 byte is 8 bits. So when you see a data size of 2 bytes, it means it is 16 bits. Then unsigned short. Unsigned short. When we talk about signed and unsigned, what a signed data type means is that it can hold both negative and positive values. A signed data type can hold both negative and positive values. But when you have unsigned, it means it cannot hold negative values. It can only start from 0 upward. So if you want to store a value that you don't want to handle negative values, so the right data type to use is the unsigned data type. So we have unsigned short. It's also 2 bytes. It holds unsigned short integer. Then we have another, the most popular in most codes, which is int, which stands for integer. The standard size for integer is 4 bytes, but it can be 2 or 4 bytes depending on the system. You know, we told you that some data types vary depending on the system. Standard is 4 bytes, but in some systems you'll discover that integer is 2 bytes, while in others it is 4 bytes, just depending on the system or the compiler. So we have unsigned int. So when we talk about signed int, that means it can hold both negative and positive numbers, but unsigned int can only hold positive numbers. It's also 4 bytes. It holds unsigned integers. Then we have long. Long stands for long integer. Yeah, it can either be 4 bytes or 8 bytes, depending on the system or depending on the architecture you are working with. Long stands for long integer. We also have unsigned long, 4 bytes or 8 bytes, depending on the system. We have long. Another one introduced in C++ 11. We have long is a minimum of just 8 bytes. A minimum of 8 bytes. Then we have unsigned long. It's also 8 bytes. Unsigned can only handle positive numbers. Then we have float. Float holds it holds numbers that accommodate decimal. Integers cannot hold decimal values, but floating data types can hold decimal values. So the size is 4 bytes. It's just a single position floating point number. Then we have double. Double means double float. It is 8 bytes, which is double precision floating point. Then we have long double. Long double can be either 8, 12, or 16. Is the extended precision floating point number. Then we have wide character type, which can either be 2 or 4 for wide characters. Okay? So let's see important consideration in handling data types. So the exact sizes of some data types, especially int, long and long double, can be implementation defined. Meaning they might vary across different compilers and system architecture. You know, some systems are 32-bit, some other systems are 64-bit. So these things can determine the size of the data type. The compiler can determine the size of the data type, and the system architecture will also determine the size of the data type. So the size varies depending on system or compiler. The C++ standard only guarantees minimum sizes and relative sizes. The C++ standard, what the C++ standard guarantees is that the character data type is either less than or equal to the short data type. Meaning that the short data type cannot be less than the character data type. So this is the order, that the character data type is less than or equal to the short data type, and the short data type is less than or equal to the integer data type. The integer data type is less than or equal to the long data type, and the long data type is less than or equal to the long data type. So that means in every compiler or in every system, this must be established. Whether it is 32-bit or 64-bit, this order is followed. That character is either less than or equal to the short is less than or equal to the integer is less than or equal to long, or long is less than or equal to the long data type. That is what C++ standard only guarantees. But the size, the direct size, is determined by the compiler and the system architecture. So if you want to determine the size, the exact size of a data type on your own system, then you can use the size of operator in C++. So when you see a code like cout, size of int, what this thing will display for you is either 2 or 4, depending on the system you are working with. If the system you are working with sees integer as 2 bytes, this thing will display 2 for you. Then if the system is maybe sees int as maybe 4 bytes, this will display 4 for you. So we're going to demonstrate this now. We want to look at on my own system. Let's see the size of bool, the size of char, the size of short, the size of int, the size of long, the size of long, the size of float, the size of double. So maybe I will still add a little, so that I will just I will write here bool. See? Okay, this is char. This is short. This is int. This is long. This is long. This is float, and this is double. So we just want to use the size of function. Okay, I have to include this in all of them. So I'll run it. Wow, beautiful. So we're saying bool is 1 byte in my system, character is 1 byte, short is 2 bytes, integer is 4 bytes, long is 4 bytes, and long is 8 bytes, float is 4 bytes, and double is 8 bytes. You see that we are trying to say that the order character is less than or equal to short. Short is less than or equal to integer. Integer is less than or equal to long. So in our case now it is integer and long is equal. Then long is less than or equal to long. Of course, float should be less than or equal to double. So this is a demonstration of the sizes of these data types, which we were able to show by the size of function. So that is what I just said. To determine the exact size of a data type on your specific system, you can use the size of operator to actually check that out. You can check it out on your phone to see what your own phone will give you. You can check it out on your own system to see what your own system will give you. It will vary, like I told you, depending on the architecture of the system and the operating system, or rather the compiler that you are using. So next is variables. Variables can be described as a named memory location in the computer system used to store and manipulate values in a computer program. It is also defined as values that are subject to change during program execution. Variables can be seen as containers for storing data values. It's very important. Any program that you'll be working with that will involve data, this data will be kept in memory. And when you keep something in memory, you should be able to access it. So the only way you can access memory is if you named your memory, if your memory has an address. So to assign address to your memory where you are keeping value, programming languages make provision for variables. So that is why we say that a variable is a named memory location in the computer system used to store and manipulate values in a computer program. Then in its technical definition, we have what we call constants, which is also a memory location too, also a named memory location for storing value. But what differentiates a constant from a variable is that the values in a variable can change during program execution. You can change the value, you can alter the value. But when you declare a memory as constant, once you assign a value to it, the value cannot change until the program is completely executed. So that's why we say that it is also defined as values that are subject to change during program execution. Variables can be seen as containers for storing values. So what are the rules to follow when you want to name a variable or an identifier in C++? These are the rules you must follow. 1. A variable name must begin with a letter or an underscore. A variable name must begin with a letter or an underscore. Then, after the first letter, the subsequent characters can be alphanumeric. That means the subsequent characters, as long as the first character is a letter or an underscore. Other characters can actually be numbers, they can be letters, a combination of both. But the first one must be a letter or an underscore. Then it can be embedded with underscore. Maybe when you have a variable name that is a compound word, instead of you to join the two words together, it may no longer give the meaning. One, you cannot space them. Actually, there can be space in a variable name. And yet, you don't want the name to be the two words to come together. What you can do is to use an underscore to separate them. So a variable name can be embedded with underscore. Keywords or reserved words must not be used as variables. That is to say, words that have special meaning to the language. Something like for, if, return. They are keywords. They have special meaning to the language. You can't use them as variable. Then, like I've said before, it must not contain space or punctuation marks. A variable, when you want to handle space or punctuation mark, the only allowed one is underscore. If you don't want to use underscore, you don't have a choice than to put the words together. So a variable name cannot contain space or punctuation marks. Variable names are case sensitive, meaning first pro, all written in small letter, is not the same thing as first pro with the first F in first being capital letter. That means a variable name is case sensitive. Whether it is uppercase or lowercase is important. If one is lowercase, F lowercase and F uppercase are not the same. So variable names are case sensitive. So let's look at some examples of valid and invalid variable names. For the valid name, A, single letter A is accepted. So a single character, a single letter can serve as a variable name. Ouchie for life, whereby we say for coming in between ouchie and life, is also allowed. My age, my and age separated with underscore is allowed. Score 1, capital numbers and letters allowed. Score, all in capital letter, is also allowed. It did not violate any of these rules we have mentioned. Then the invalid ones, we are seeing 2. 2 is not a variable name. 5 star, because it's starting with a number, is not a variable name. My age, because there is space between my and age, is not a variable name. Score.1, because of the punctuation mark dot, is not allowed. Float, because float is a keyword, it is not allowed. So those one are invalid. They can't be used as a variable name. So how to declare a variable in C++? In order to use a variable in C++, we must first declare it, specifying which data type we want it to be. So what we say to declare a variable means you want to assign a variable to belong to a particular data type. The syntax to declare a new variable is to write the specifier of the desired data type, like int, bool, float, then followed by a valid variable name. For example, the specifier here is double. Double is the data type. So when we say double amount, double is the data type while amount is the variable. If you check, amount did not violate the rules for naming variables. So this is an acceptable variable declaration. Unsigned int age is also acceptable. Unsigned int is the specifier, data type specifier, while age is the variable. Float score is also acceptable. Int var1, var2, var3, meaning that you can actually declare more than one variables in one line if all the variables belong to the same data type. So in this case now we have integer var1, var2, var3, meaning var1, var2, var3 are all integers. So instead of doing int var1, int var2, int var3, I can actually do it in one line as int var1, var2, var3. And take note, variable declaration also ends with a semicolon because it's also a statement. So it ends with a semicolon. So initialization of variables. When we talk about initialization, how to assign initial value to variables. When declaring a regular local variable, its value is by default undetermined. You know, I said this when I was talking about constructor, that the initial value in a variable is not determined by you. You don't even know what, when you declare a variable, if you don't initialize it, what it contains. You know, we say the variable is like a container. What is inside that variable, we don't have control over it. So, that will say, but you can assign a value to a variable at the point of declaration, so that you will be the one to assign a value to it, so that whatever is in that variable is determined by you. So that is the essence of initialization. This is called variable initialization. This is called variable. There are two types or two ways of doing variable initialization in C++. One, we have the C-like initialization. We have the C-like initialization. Then we have the constructor initialization. The C-like initialization and the constructor initialization. So let's look at the C-like initialization. It's something you are very familiar with because of your background in C language. So this is done by appending equal sign followed by the value to which the variable will be initialized. Appending equal sign followed by the value to which the variable will be initialized. So look at the syntax. Data type followed by the variable name followed by the equal sign, then followed by the value you want to assign to the variable, and then a semicolon ending it. For example, if you want to declare an int variable called amount, initialize it with a value of 100 at the moment in which it is declared, we can write it this way: int amount equal to 100. So this is initialization. So at the point of declaring this data type and this variable amount, we are also determining the value that will be in it. So this is the C-like way of initializing a variable. Int, which represents the data type; amount, which represents the variable name, followed by the equal operator, and then the equality sign or equal sign, then the value we want to assign here, 100, and then semicolon. Then let's look at finally the constructor initialization. The constructor initialization, how does it look like? The other way to initialize variable, known as constructor initialization, is done by enclosing the initial value between parentheses. So you specify the type, the variable name, which is the identifier, then the initial value. Example, int amount. Instead of equal to 100, you open brackets, put 100 inside. You have actually done this initialization. So that is the constructor way. If you remember the constructor class we did, that when you want to create an object, you provide the values for that object through parameters. That's actually what we'll talk about, the constructor initialization format. The data type, the variable name, open bracket, put the value inside. We have come to the end of the class. Thank you so much. God bless you. See you in the next class when we'll be looking at C++ operators. Thanks.